Question 1. So we've got to work out the length of BC. Now it's a right angled triangle. We've got two sides and we're trying to find out the third side. So this is going to be Pythagoras. And because we're working out the hypotenuse, which is the longest side, it's going to be an adding Pythagoras. So we can say that BC equals the square root of 9 squared plus 6 squared. Popping that into our calculator, we get 10.8166 ... So to three significant figures, that means 3 digits in total, that's 10.8. Question 2. So Jack drives at an average speed of 48 kilometers per hour. Work out the distance he travels in 1 hour 40 minutes. So really the only catch here is not to fall in the trap of thinking 1 hour 40 minutes is 1.40, because of course it's not. We've got 40 minutes in an hour. So 1 hour and 40 minutes is 100 minutes. So I think the best way to do this, my preferred way, is you just do it by proportion rather than relying on that triangle thing. So traveling at an average speed of 48 kilometers per hour. So we go 48 kilometers in an hour, or we go 48 kilometers in 60 minutes. But we're traveling for 100 minutes, so we need to scale this up to see how many kilometers we would go in 100 minutes. So you could divide this by 60 to take you back to 1 minute and multiply by 100, or you could do what I've done. What I've done, I've scaled it back to 10 minutes by dividing by 6. So dividing both of these by 6, I'm saying we can go 8 kilometers in 10 minutes. So timesing that by 10 to get to our 100 minutes, 8 tens are 80. So we would go 80 kilometers in 1 hour and 40 minutes. Question 3. So the probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times, work out an estimate for the number of times the dice will land on a 5. So if we roll it once, the chances of it landing on a 5 is 0.3. So if we roll it 400 times, it's going to be 400 times this. So simply 400 times 0.3, which is 120. Question 4. Ali was asked to solve the equation here. Here is his workings. They make a mistake. What mistake did he make? Right. Well, what he's done the claw wrong. So we should do 3 times x and 3 times 4. He's done the 3 times x, okay, but rather than do 3 times 4, which is 12, he's done 3 add 4 to get 7. So Ali did 3 plus 4 instead of 3 times 4. Question 5. So we've got 140 grams of liquid A, so that is the mass of liquid A, and we've got 128 grams of liquid B, and they're mixed to make liquid C. Work out the density of liquid C. So okay, so to start off with, I think you've really got to learn that density equals mass over volume. And then if you've learnt that, you just need to be able to manipulate this to make either M or V the subject. Now I'm going to want to work out the volume of each of these liquids, so I want volume to be the subject. So to do that, I first of all multiplied by V. So D times V equals M, and I've then divided by D. So volume is mass divided by density. So I can work out the volume of A by doing the mass of A, 140, divided by the density of A, which is 0.7, giving me a volume of A of 200. My volume for B is the mass of B divided by the density of B, so 128 divided by 1.6, which is 80. So the volume of A is 200, the volume of B is 80, so my total volume is 280 centimeters cubed. Now my total mass is just going to be the 140 add the 128, which is 268. So I have the total volume, the total mass. So to work out the total density, I take the mass total divided by the volume total. So back to the original formula. So 268 divided by 280 which is 0.957. Question 6. So Claire is making a loaf of bread. A loaf of bread loses 12% of its weight when it is baked. Claire wants the baked loaf of bread to weigh 1.1 kilograms. Work out the weight of the loaf of bread before it is baked. So first things first, let's work out the multiplier. Well, we're losing 12%. So think of 100 take away 12, which is 88. So our multiplier to get a 12% loss is 0.88. Now this is a reverse percentage situation. We're trying to work out the original weight when we know that the final weight is 1.1. The baked weight is 1.1. So our original weight times 0.88 equals 1.1. So dividing both sides by 0.88, our original weight is 1.1 divided by 0.88, which is 1.25 kilograms. Question 7. So the value of a van depreciates at the rate of 20% per year. So it loses 20% of its value each year. Gary buys a new van for $27,500. After how many years is it worth this? So again, the starting point is to work out our multiplier. So if we're losing 20% each year, our multiplier is going to be 100 take away 20, which is 80. So dividing that by 100, a multiplier of 0.8. Now we're going to do this by trial and error. So we're going to take our 27,500 and multiply it by 0.8 to a guess of the number of years, which is the power. So I'm going to start off by trying 3 years. So popping this into my calculator, I get 14,080. So the van hasn't depreciated enough. It must be more than 3 years. So I've then tried 4 years. And on this occasion is bang on, because 27,500 multiplied by 0.8 to the power of 4 does indeed give me £11,264. So I've used a power of 4, so it is 4 years. Question 8. Now we've got to work out the size of angle A. Now this is trickier, because this is not a right angle triangle. So we're going to have to use the cosine rule, and we're going to have to rearrange it so that we have really the angle as the subject rather than a length. So we are given the cosine rule. It's in the formula sheet at the front of the paper, which says that a squared equals b squared plus c squared minus 2bc cos a. Remember, the lowercase a, b and c are the sides, and the uppercase a is the angle. Now, we need to be able to rearrange this, and it's not very difficult to rearrange it. We're trying to make cos A the subject. So you start off by adding the whole of this term, by adding 2bc cos A. Oh, I think I've missed out a c there. That should be 2bc cos A. 2bc cos A. So excuse me, there should be a c written there. Let's just go and pop that in. So that's 2bc cos A. 2bc cos A. I've done it left further down. So that's 2bc cos A. So adding 2bc cos A to both sides, and at the same time I'm going to take away the a squared from both sides. So that gives me my 2bc cos A equaling b squared plus c squared minus my a squared. And then I've gone and divided both sides by 2bc. So I've got cos A being the subject. So cos A equals b squared plus c squared minus a squared all over 2bc. Now, A is my angle, so that's how my diagram is presently labelled up, with capital A being the angle that I need to find. So I'm following the blue referencing here. That red referencing comes up in part B. So following the blue referencing, I've got b squared plus c squared, so that's 1.8 squared plus 2.7 squared, minus a squared, so that's minus 3.6 squared, all over 2 times b times c, so 2 times 1.8 times 2.7. Now popping all of that into my calculator, taking advantage of that fractions button on your calculator, that one about 3 down on the left where you've got the square over the square, I can see that cos A equals something, so whatever you get for cos A, inverse cos that answer, and that will give you 104.477 ... to 1 decimal place is 104.5. Now for part B, we've got to work out the area of the triangle. Now again, we referred to the formula sheet and we got told that the area equals half AB sin C. So for some reason they're now calling the angle C. So rather than change the formula around, which you can do, but I prefer just to annotate my diagram to tie in with the formula. So I'm now going to make C be the angle. So that's why I've got the capital C up there. So this 3.6 has now become my little c, and my 2.7 has turned from being the little c to the little a. So just substituting into the formula half AB sin C, I'm going to have half times A, which is 2.7, times B, which is still 1.8, times sin 104.477 dot dot dot. So use the more accurate working up here, don't use your rounded one. Popping that all into your calculator, I get 2.352, which is to 1 decimal place 2.4 centimeters squared. Question 9. So D equals x over y. X and y are these when they've been rounded to 1 decimal place and 2 sig figs. Work out an upper bound for D. Now, if you're trying to work out an upper bound when you're dividing, you want the numerator, the top number, to be as big as possible. So that's going to be the upper bound for x. But you want the denominator, the y value, to be as small as possible. So that's going to be the lower bound for y. So we're going to do the upper bound for x divided by the lower bound for y. Now x is correct to 1 decimal place is 99.7. So the biggest that could be is 99.75 and the smallest 99.65. Remember the symmetry. When we're doing bound questions, we go up and down the same amount. So we don't worry about the nicety that 99.75 would actually in the real world round up. We think upon this as being 99.749 recurring. It's effectively the same number. So don't overcomplicate things. Just roll with the 99.75. Do not say 99.74, for example. Same with y. Our lower bound is going to be 66.5. So we've gone down 0.5. We go up 0.5 for upper bound, 67.5. So we wanted the upper bound for x. So the bigger x1, that's 99.75. Divided by the lower bound for y, the smaller one for y, the 66.5. Popping that into a calculator, we get exactly 1.5. Question 10. So for part A, we're being asked to find f of 3. So that's simply what happens when we put an input of 3 into the f function. So we just pop 3 into this. So 2 3s are 6, 6 add 5 is 11. Now for part B, we're being asked to find g of minus 3, so that's just when we put minus 3 into the g function. So popping minus 3 into this. Now be careful, minus 3 squared is plus 9, and minus times a minus is a plus. So if you're going to rely on your calculator to work that out for you, you must protect the minus. You must put the minus 3 in a bracket before you square it. So it's 9 take away 25, which is minus 16. Now for part C, we've got to find fg of x. Now this is when we put the g machine, the g function, into the f function. So we're popping x squared minus 25 into 2x plus 5. So that x is being replaced by x squared minus 25. So it's 2 lots of the x squared minus 25. And then plus the 5 afterwards. So with the claw, 2 lots of x squared is 2x squared, 2 lots of minus 25 is minus 50. Gather up the minus 50 and the plus 5, we get 2x squared minus 45. Now for part D, we've got to work out the inverse function for x. This requires us to change the subject. So choose to let y equal the function. Let y equal 2x plus 5. And change the subject to make x the subject. So we take away 5 from both sides, giving us y minus 5 equals 2x. We then divide by 2, so y minus 5 all over 2 equals x. Now remember, y is just something we've artificially introduced. So we replace the y with x. So our inverse function for x is not y minus 5 over 2, but x minus 5 over 2. And remember what this does. This undoes what the f function does. So when we put 3 into the f function, our output was 11. So we had an input of 3, an output of 11. This inverse function does the opposite. So if we take that output of 11 and pop it into this inverse function, 11 take away 5 is 6, 6 over 2 is 3. So the output of this was the input of the f function.